so we have been looking at this as a currency, and blockchain is like this thing, right? That just keeps growing, and that's the kind of like, think of this as like a journal or a data structure. In computer science, like, there are different types of data structure. It's a new type of data structure or technology, and interestingly, it's a file. So you might have heard the term blockchain, and people have like some sort of vague idea about what it is. If you want to look at a blockchain, it's literally a file. You can download it, right? Like it has a file with like different like sub-files in it. And this file only grows, like imagine like it can only grow in one direction. You can never erase data from it. You can only add more data to it, right? So in that way, it's like a journal. You fill some pages, you can fill more pages, you can attach like another like extra pages and keep filling them, but you can never erase data. That's what a blockchain is. And anyone who wants to participate in this network has like a full copy of it. Like in terms of like if you want to be a miner or if you want to connect to the node, like normal users don't need to have a copy. They can just sign transactions and send it out. I'll explain how that works in a bit. So this is the example of like, a bunch of people, they want to be on the Bitcoin network. So it's a network in the sense that everyone can talk to pretty much everyone else. And I talked about leader election a little bit, where one node solves the puzzle and gets to write the new block, right?
That's a little complicated. What?
So so the problem over here is, so here's the problem we're trying to solve. It is a network of computers, and we have this blockchain, and a new block is coming in that is going to give this person 50
like new
bitcoins
is like
right?
what we're talking about. Okay,
yes.
okay.
So who gets it? Everyone will try to get it, right? It's real money. Like they can just actually convert it to dollars like straight away. And so they are all trying to solve a puzzle, and whoever solves the puzzle, maybe turned out to be this person, gets to write the new block and get the bitcoins. Right. So this is a way to have like this system in place where no single party is in control, because there's no guarantee that this person will get to write the next block as well. Because when the next block is coming, you go back to solving the puzzles, right? And it's very random. Yeah.
Why are they together then?
In the sense that why are they collaborating?
Yeah.
So they're all not really collaborating with each other. They're all playing the game. They're on the network. Okay. All of them are saying, I want to play, right?
So they're like competing.
They're kind of like competing.
Yeah.
Okay. And so now, like, I'm going to switch gears. This was more about like how the protocol works internally, but for most users, they don't need to know all of this, right? Like they're like, hey, I just want to use this thing. How do I use it? And how does that work for me? How is it more secure? Like, how is it more private? So now we're going to like go a little bit into that, and then also explain like how as a user you would interact at a slightly more technical level as well. So what happens is that there's this concept of a private key and a public key, right? The private key is your secret. Think of this as you're literally your key to your house or something, right? Like you're not supposed to give it to someone else. You're not supposed to share it with anyone else. And the public key is kind of like, think of that as like a pair, that the public key can be derived from the private key. And that information you can share with anyone, right? So, but because no one knows the private key other than you, no one else can prove the ownership of the public key, right? Let's do it again.
Yeah, try it again.
Okay. So imagine two large numbers, right? They don't mean anything. They're like gibberish. Actually, I can show you. This is what a private key looks like.
That's like your bank account number. Like you get one of these.
You can't derive it.
Okay.
That comes later. But imagine like gibberish, right? Like just very like imagine an extremely strong password where you just like start typing like crazy and you come up with something like this, right?
Okay.
That people would not be able to reproduce it. Like there's like very low probability. This secret, extremely long, very secure password can be converted into a public key that is okay for you to share that public key, right? So imagine that it's like the private key kind of like owns the public key, but the public key is shareable. You can tell people that, yeah.
So is what we're trying to solve or talk about is like how you can keep security, but
Yes.
also have all your transactions public.
Yes, it's basically like imagine if the analogy is the Facebook username and password.
Oh, okay,
The
yeah.
public key is the username. You can tell people your username or Twitter handle, right? The public key is kind of like your Twitter handle, but the private key is your password that you're supposed to keep secret. Otherwise, someone will steal your Twitter name because they will just be able to log in,
Got it.
right?
Makes sense.
So that's what private and public keys are. And whenever you think of private keys, just imagine like you typing on a keyboard like crazy and coming up with this number. Actually, even that would not be that random. There are mathematical properties behind how random this number is. That to generate it, you would need more energy than is present in the universe.
What?
Like so that goes back to your security question. So if you actually don't share your private key ever with anyone, like no one can just randomly hack you.
So it's very secure.
It's like from a theoretical perspective, it's extremely secure. Most of the attacks that are possible are more like everyday attacks on like the software or the UX or the laptop. So what a lot of people who own Bitcoins, they actually have computers. This is very fascinating. They have computers that they have never connected to the internet. They have computers that they've never used where they think there might be public cameras somewhere. So it's like, imagine this like secure laptop
Yeah.
that you have never connected.
Yeah.
You haven't installed any like random software on it ever. And you generate your private key on that computer, like sitting in a dark room so that, you know, and then you use that private key to keep your Bitcoins on the account that is owned by that private key.
Whoa.
Right. So, and there are companies that do like, you can actually store your private keys in cold storage in banks and vaults. Like imagine now people are keeping millions of dollars of their money in Bitcoins. So imagine the level of security around these private keys that
Wow.
like you would need signatures from multiple people before
Yeah.
a transaction can happen, and like all of that stuff is
Wow.
yeah.
Some password.
Get like extra money for it,
Like-
money.
like
I mean,
like in
is it only like I can only use it, let's say, on the internet to buy things, or can I actually get money?
yes, you can, absolutely can. So what's happening is that there are companies which are called Bitcoin exchanges,
Yeah.
right? And they act like, you know, how you can convert your euros to dollars, you convert Bitcoins to dollars.
Okay.
And people now, there are professional traders who actually trade this currency, and it's
I
like,
think there's even like an ATM in Brooklyn
Yes.
that you can put your money into and get, because I heard it on Radio Lab, there was a
Yeah.
story of this like grandma that had to go
Yeah.
and do this.
yeah.
Is there like any amount that they cannot exchange, or is it like?
So it
whatever
really,
that-
so think of this as like that is dependent on that company, like how many Bitcoins they have, how many do they have in store, and like what's the exchange rate right now. And there are multiple companies now. There are like a bunch of
So if I
exchanges.
have, like, a couple of millions,
Yeah.
I probably have to.
So one of the companies I mentioned, Coinbase, who have raised like $100 million, they are an exchange, right? So they keep actually millions of dollars in Bitcoin for their customers. So basically, we already talked about this. So what I said the public key was, like, which is like a username on Twitter, it can be something like a bank account number as well. So imagine that you can convert that into something like a bank account number, and looks like this. And this is what people use for Bitcoin payments. So imagine that you can convert that into something like a bank account number and looks like this. And this is what people use for Bitcoin payments. whenever they say, hey, give me your Bitcoin address, I want to send money to it, it's this address.
The
Which-
public,
the-
this one.
It is derived from the public key,
Okay.
right? So it's technically it's like a hash, double hash of the public key, but you don't need to know that. It's basically think of it as a bank account number. But the interesting thing is that it's not like your bank account number for the rest of your life, because I can generate new addresses very, very quickly. Like imagine like instead of creating one private key on my computer, I can create 1,000 or more. Like it's like within it doesn't take that long. Right? So I can have like as many accounts as I want, and I can use them.
So it's much more secure because if you have somebody's bank account,
Yeah, exactly.
you can't change it.
Right. So some people even say you should just use one address only once and just throw it away
Wow.
and move like. So imagine like if I had $20 in my account, I wanted to send you 10. I send 10 to you, and I send 10 to an address that I own, but it's a new address. So no one really knows like how
Wild.
the money is actually flowing in the system. So now let's try to make a transaction, right? Like you're just a user. You know that. So there are companies now who actually make these Bitcoin wallets. So it's like an app. You download the app. You send yourself some Bitcoins from an exchange, right? You bought either like the app will have the functionality that you can just say fund your account, convert $5 to Bitcoins, or you would send yourself money from just like you can treat some of the exchanges as your bank account, and then you're kind of like sending money to an app that is your wallet, and you can use that for payments. You can like buy coffee with this. Like there are a lot of merchants who are accepting. I think Target started.
Really?
Yeah, there are some big companies like Microsoft accepts payments in Bitcoins for certain things like the Xbox or.
Oh, cool.
I'm not exactly sure what product it was, but it's like definitely there's a massive increase in people who are accepting Bitcoin as payments because they're actually not taking that much risk, because you can set up your website that you can accept the payment in Bitcoin, but as soon as you accept it, you cash out $2.
Oh, wow. And then
you-
there's probably not a transaction fee like credit cards have, huh?
Yes, so
2.9.
the Bitcoin transaction fees are very low.
Yeah.
There are fees,
Oh, there
and
are,
that
huh?
is actually that didn't come up in the discussion about how new money is getting introduced. The second form of payments is actually transaction fees, which are very small.
Okay.
But if there are enough transactions, the miners can collect fee from, let's say, 1,000 transactions.
Yeah.
And so that's another incentive for these people to keep running their computers on the network, because when, let's say, a couple of decades from now, the amount of new money being released goes down, still there will be transaction fees, and Bitcoin would be a lot more valuable by then. So they would still want to continue running the network because of the transaction fees.
I mean, and the reason we need all the computers on the network is because that's where the log is, right? It's like distributed,
Yeah.
like everybody has a copy.
Exactly. And another way to think about it is if a large bank is running computers and the infrastructure,
Yeah.
right? They're collecting fees from their customers, and they are responsible for running the infrastructure, but now you're dependent on the bank. This is Bitcoin's way of getting people to run all of these servers and infrastructure, and it's being operated in a way that no single person is in control. But still there's massive computing and networking power behind the technology, and which is fine. Like you don't care like how the infrastructure is run. It's actually better for me if no single company has control over it, right? And the protocol just figured out a way to give people incentive to basically plug in their computers and help the network.
Got it. Cool.
So let's say you want to do a transaction. The transactions are, you can just think of it as like writing a check. Just like you sign a check, you can sign a transaction with your private key. And that's all there is. So if I want to send, like, let's say a Bitcoin to Chris, I would need to know his Bitcoin address. Then I will sign the transaction with my private key. And so most of these wallets and exchanges would take care of this for you, right? Like you wouldn't even notice. It would feel like a normal payment to
Just
you.
press send.
Yeah, they would just, you would just say
yeah.
click on send, and they like things would just happen. But at a more technical level, what's happening is, let's say I wanted to send it from my laptop using the open source software or something, right? So I would create this transaction, sign it with my private key, and broadcast it to the network. And in the network, what happens is that the next block is being prepared, like over here, right? So remember that any change that happened or any transactions that happen, they go into the next block. So some miner, whoever wins the puzzle, will take all the transactions, pack them, and basically write the next block of the blockchain. Because the miner is getting transaction fees from the transactions, so the miner has incentive to include your transaction as well. And interestingly, sometimes people send transactions with no fee, and sometimes miners just accept that as well. I think there was a famous transaction where the money that was being exchanged was in the order of millions, and the transaction fee was 0, but someone still included that, some miner still included that, and the transaction went through. So it became like a meme that in Bitcoin you can actually transfer millions of dollars and pay 0 in fees. But usually the fees is actually in the order of cents. Like I usually pay like 20 cents for making a transaction.
For a transaction.
Yeah, and it's usually good enough that miners will pick it up very quickly.
Huh. Fascinating.
So this is how like they pack transactions, and then the blockchain just basically keeps growing. And I'm gonna skip this slide. This is about the actual how the puzzle works. But if people are interested in like how the puzzle is designed, I can explain it. But that was you are okay. So here's how the puzzle works, right?
Okay.
So there are 2 conditions or 2 properties that the puzzle should have. It should be very hard to calculate, but very easy to verify that you got the right solution, right? And it should be dependent in some way on the previous history, right? So that you know that you're working on the next block. So what happens is that, so this is a block that is currently being prepared, and it has not been written yet, right? So it has a reference to the previous block, right? And you have a bunch of transactions here. So the miners are supposed to like take all of this information, including the pointer to the previous block, right? And hash it. So hash functions are where you just take a bunch of data, and it's a one-way operation. And it basically, it's deterministic, that whatever data you basically give to the hash function, it will give this. If you give the same data, it will give the same output. So it basically converts any data. Let's say I give it A, B, C, D, E, F something. It will output some string of characters or numbers, which will always be the same if I give it the same input. Right? So it's like a one-way hash. It gives you like a hash for a certain value. So what these people are trying to do is that they're taking this data, which is constant, right? Everyone has the same data. And then they have it's called a nonce. This value they can change. So they're like changing the nonce again and again to get different hashes.
Just random generating
randomly.
numbers,
So
random
imagine
numbers.
as soon as the next block comes in, everyone like just fires up their computers, and they're calculating hashes upon hashes upon hashes, right? Because they're just incrementing this nonce and just randomly what they're trying to get at is, for some value of this nonce, you will get a certain number of zeros at the beginning of the hash. So the hash looks something like this, right? But the probability of hitting that is actually very low. Wow. So you are kind of like basically doing a brute force attack to randomly get a hash that matches this criteria. As soon as you hit that hash randomly, you tell everyone, hey, I got it, give me Bitcoins. Right? So, and it's very fascinating the way they designed it, because the protocol is actually even intelligent enough to see how many people are playing the game. If, let's say, for some reason it's not profitable for you to mine anymore, let's say the cost of electricity is a lot, and you're actually losing money because you just don't find the hash realistically over time, and you, let's say half of the network just drops out.
It
Like,
gets
hey,
easier?
I don't want to play it anymore.
Yeah.
The game becomes easier.
Get out of here.
Seriously.
That's cool.
So, and usually how that happens is technically they would drop a 0. So now it's easier to get 4 zeros in the beginning randomly than it is to get 5 zeros. Like imagine like you're playing
oh yeah.
cards or something. The probability of you getting like an ace is actually much lower than getting ace and an ace, right? So
Yep.
the zeros are like that. So the protocol actually adjusts and give everyone's like, hey, there's free money on the table. Now it's easier to mine. Why don't you plug your computers back in? So it like keeps actually giving incentives to people
Wow.
to be part of the network.
That's awesome.